Okay, integration by substitution. Next topic, next exercise of integration topic. So first exercise is over. I have solved 20 out of 20 problems. In 18, 19 or sorry, 10 or 12 problem I have solved. Remaining simple problem I left it as homework. Okay, now integration by substitution. So I told you in integration the main technique is converting the integrand means in integration of f of x dx. This f of x is called integrand. This is to be converted to a form where you can apply the integration formula. ಇದನ್ನು ಒಂದು ಫಾರ್ಮ್ಗೆ ತಂದ್ಕೋಬೇಕಾಗುತ್ತೆ. ಆ ಫಾರ್ಮ್ನಲ್ಲಿ ಹೇಗಿರಬೇಕಾಗುತ್ತೆ, ವಾಟ್ ಫಾರ್ಮ್ ಯು ಗಾಟ್ ಫಾರ್ ದಟ್ ಫಾರ್ಮ್ ಇಂಟಿಗ್ರೇಷನ್ ಫಾರ್ಮುಲಾ is applicable. As it is from integration formula will not be applicable for majority of the problems. Okay, so that conversion technique is made. So one of the technique to convert integrand into integrable form is the substitution method. Okay, so substitution for a function. So what for substitution for what is to be taken by, you will understand by the problem. Okay, the integrand can be converted. Integrand can be converted in bracket integration of f of dx. In f of x, integration of f of x dx, f of x is called integrand. F of x is called integrand. F of x is called integrand. Okay. Can be converted. The integrand can be converted by substitution method. Substitution method. An example I will take. Integrate the following. Example. Integrate integration formula is integration I'm sorry, not integrand, integer, integration, not INTI. I might have written INTI, not INTI, INTE. Integrate the following. Integrate the following. Okay, first one is integration of, it is ax plus b whole raised to n dx. First one. Second one, integration of 1 upon ax plus b, okay, dx. And third one, integration of sin ax plus b dx. First these three letters. Actually, integration of x raised to n is integration of x raised to n dx is x raised to n plus 1 upon n plus 1. Okay, integration of x raised to n is x raised to n plus 1 upon n plus 1. But integration of ax plus b whole raised to n is ax plus b whole raised to n plus 1 upon n plus 1 is not complete answer. Okay, so only in integration is given for x raised to n, then integration of x raised to n is x raised to n plus 1 upon n plus 1, but not ax plus b whole raised to n. Integration is ax plus b whole raised to n plus 1 upon n plus 1. It is not the correct answer. Okay, then how to integrate it? By a substitution method. Look here. So just you remember write down all the three. First one, take integration of the formula. It is to be remembered as a formula also later on. Okay, so I will tell you one technique to remember these formulas. Okay, so it is integration of ax plus b whole raised to n dx. Now I will take substitution. Here comes a substitution for the old variable ax plus b. I will tell you old variable is x. Not only for x the substitution, for a particular equation you have to take the substitution. That is t is equals to ax plus b. Okay, t is equals to ax plus b. Now this ax plus b is taken as t. That is the substitution taken. Okay, let t is equals to ax plus b. Now what happens? T raised to n dx. It will become ax plus b is taken as t. No, t raised to n dx. Wrong. Why wrong? I told no. T raised to n means here it should be dt. Z raised to n means here it is z dz. The variable of integration is theta. Theta raised to n means here it is d theta. So here f of theta, function of theta, then here comes, here it should be d theta. Integration with respect to theta. F of theta can be integrated with respect to theta, means d theta should be there. Therefore, t raised to n dx is absolutely wrong. You can't integrate function of t with respect to x. With respect to t is necessary. Therefore, by differentiating, I can convert dx into dt. Okay. So now you have to differentiate this function to convert dx to dt. Okay. So note, I will give you a note here. No need to write the note for examination. Differentiating the above equation, we can convert dx to dt. In place of dx, now dt should be there. Okay. By differentiating, that is the one basic technique. Whenever substitution is taken, you have to make the substitution. Sorry, by differentiating, you have to what it is, convert dx to dt. Okay. By differentiating, whenever substitution is taken, then immediately differentiation is very must. Okay, to convert dx to dt. By differentiating, we can convert dx to dt. We can convert dx to dt. Okay, dx to dt. Differentiating with respect to x, it is dt by dx. Differentiation of t, dt by dx. What is the differentiation of ax plus b? A into constant d by dx of x plus d by dx of b. Is it not? Whenever plus or minus is there, you have to differentiate each and every term. During that differentiation, the constants are there. So a and b, a, b, c, d, f, g, h, I, k, l, m, n, p, q, r are constant in simple differentiation, not in application of differentiation. A and b are constant, they are taken outside. Therefore, so space is insufficient here. So I will continue here, check continuation of this one. But this is not the because part, it is the main part of integration. This, when your substitution is taken, you have to show the differentiation and you have to convert dt to dx. That a part is to be displayed. Okay, very big that part is to be written. It is not the because part. So you must write all these things. Whenever substitution is taken, differentiation, you convert it to d2 to dx. That must be written in the examination. Okay, so therefore dt by dx is equals to a into differentiation of x with respect to x is 1 plus b differentiation is 0, a into 1. Therefore by cross multiplying, so dx is equal to, by cross multiplying, dt upon a, here is a, no, equals to a into 1. Differentiation of x with respect to x is 1, b constant differentiation is 0, a into 1 is a, therefore dt by dx is a. Therefore what is the dt by dx? Dt by dx is equals to a. Therefore here comes dx by cross multiplying, dt upon a is equals to dx. All these are taken. Here t raised to n. Now I have taken this ax plus b is coming to the main integration. Ax plus b is taken as t raised to n. Then dx is, here dx is written wrong. Here variable of integration is t. Then here it should be with respect to t only. T can differentiate, integrated with respect to t only. Therefore dt is necessary. What is dt? In terms of dx. This dx is nothing but dt by. Therefore take dt by. That's all. This is the technique of integration. So by integration, by substitution. Now what is the benefit of that? Look here. As it is for this function, no integration formula. Now t raised to n integration, just like x raised to n. T raised to n, x raised to n, y raised to n, z raised to n, theta raised to n, all are in the same formula. Integration of theta raised to n, d theta is theta raised to n plus 1 upon n plus 1. Y raised to n integration is y raised to n plus 1 upon n plus 1. Integration of t raised to n dt is t raised to n plus 1 upon n plus 1. That's all. So therefore now 1 by a constant, dt upon a, 1 by a. It is 1 by a, dt upon a means dt into 1 by a. 1 by a is constant. That constant is taken outside. 1 by a is taken outside. Integration of t raised to n dt. Now there is a formula for t raised to n. Now look here. By substitution technique, I have converted this integrand to a form where I can apply the integration formula. For t raised to n integration formula is there. T raised to n integration is same as x raised to n. Variable may be t or x or y, then integration formula is same. That's equals to 1 by a into t raised to n plus 1 upon n plus 1. It is x raised to n integration. Outside noise and outside noise is working. So that is the main problem. One problem. Okay. So t raised to n plus 1 upon n plus 1. X raised to n integration is x raised to n plus 1 upon n plus 1. So for the answer is 1 by a, or it is 1 by a into t raised to n plus 1 upon n plus 1. But finally you get back to the original variable. Integrand is in terms of the x. Therefore, integral means the answer is also in terms of x. What is the t then? T is nothing but ax plus b. After integration is completed, then from the you convert to the you get back to the old variable by the same substitution. Ax plus b, t is ax plus b. No, therefore ax plus b whole raised to n plus 1 upon n plus 1. Okay. Plus c. Therefore, you have to remember it as a formula. Integration of ax plus b, therefore integration of ax plus b raised to n dx. That is the integration by substitution, by proper substitution. You can convert the integrand to a form where you can apply the integration formula. So it matches to integrand, matches to the form where integration formula, in integration formula chart, there is a formula for this particular integrand. So that is the technique of integration by substitution method or by rationalization, factorization, etc. By using trigonometric results, you have to convert the integrand to a form where you can apply the formula of integration. Actually, an integration is nothing but simply applying the formula only. But converting it to formula to a stage where you can apply the formula, that conversion technique is main. Okay, it consists of all types of mathematics. Conversion technique. It consists of varieties of techniques actually. Ax plus b raised to n dx is ax plus b raised to n plus 1 upon a into n plus 1. Okay, plus c. So one inference, one result, one idea you can have from this particular integration. Look here, if x raised to n is there throughout the integration, this technique you have to remember. If x raised to n is there, then it is x raised to n plus 1 upon n plus 1. But in place of x, in any integration formula, I have given 20 integration formula out of that 20, 18, 19, 20 are simply the when k into f of x integration and integration of plus or minus like that. No, but in first 18 integration formulas, if in place of x, in place of sin x, in place of e raised to x, in place of x raised to n, in place of 1 by x, in place of what it is, cos ax plus b, in place of tan x, if in place of x, if ax plus b is there, then same formula of integration is applicable. But upon a is additional, that is the one technique you have to remember. So we have derived so many integration formulas later on. But in place of x, if ax is there, or ax plus b, because b may be a zero constant, b may be 0 also. If b is 0, then ax plus b simply reduces to ax. In place of x, either ax is there or ax plus b is there, same integration formula applies. But one factor additionally will be divided, that factor is 0. That's all. Coefficient of x will be divided. X raised to n, what I mean is x raised to n integration, x raised to n plus 1 upon n plus 1. But in place of x, ax plus b is there. And same formula, x should not be taken, the whole ax plus b is taken. In place of x, ax plus b is there, and the integrand also in place of x, ax plus b will be there. Ax plus b raised to n plus 1 upon n plus 1, but an additional factor a should be divided. What is a? It is the coefficient of x. Okay. So that's why you can tell the integration for this one also. Second one, you can tell the answer for the second one also. 1 upon x integration, log x. 1 upon ax plus b integration. In place of x, ax plus b is there. Therefore, that what I have explained, that technique is applicable. Now it is log ax plus b upon a. In place of x, ax plus b. 1 by x integration, log x. In the first 20 formulas list, it is there. 1 by x integration, log x. If in place of x, ax plus b is there, 1 upon ax plus b, then say log of ax plus b upon a. And a will additionally should be taken upon. So sin x integration minus cos x. Therefore sin ax plus b integration minus cos ax plus b upon a. Then integration of cos x is sin x. Therefore cos ax plus b integration sin ax plus b upon a. Even b may be 0 also. Sin ax integration minus cos ax upon a. If b may be 0 also, then automatically only ax remains. Then also same formula is applicable. Okay. So that is that. One technique you have to remember. If any integration formula is derived for x, then in place of x, if ax plus b is there, then same formula of integration is applicable, but an additional factor upon a is to be taken. That's all. For example, integration of, I will take one the example on it. Integration of 2x plus 3 whole divided raised to 5 dx. N belongs to R except minus 1. N is any real number except minus 1. In x raised to n integration also same. 2x plus 3 raised to 5 dx. It is equal to 2x plus 3 raised to 5 plus 1 upon 2 into 5 plus 1. Because a is 2, n is 5. In this particular case, a is 2, n is 5. Therefore, ax plus b raised to n plus 1 upon a into n plus 1. A is 2. Coefficient of x is a. That's equal to 2x plus 3 whole raised to 6 upon 5 plus 1 is 6, 6 to plus c. Second one. So, too many syllabuses are removed actually in each and every topic. Actually, a little bit syllabuses are removed. So, some difficult section in what it is, integration in what it is removed, and in matrices and determinants using the properties, expansion of the determinant by using the evaluating the determinant by using the properties of the determinant. R1 is equal to R1 plus R2 plus R3. That is removed. That is the most difficult part for the student. And in integration also some part is removed. In differentiation actually simple differentiation is removed, but in application rate measure is removed. So like that few parts are removed. Okay. So integration of, and in statistics binomial theorem, actually an easy section. It is there for second year commerce student, and it is 5 marks pocket marks section. Actually only question for 5 marks. Every year they used to ask, and this year that section is removed. An easy section actually. It is there for second year commerce student also, arts students also in statistics. Okay. For example, second one, integration of 1 minus x raised square root of 1 minus x raised to dx. That's the first one. Square root means it is 1 minus x raised to 1 by 2 dx. Square root means raised to half. N is any real number except minus 1. N is any real number, fractional value, integers, irrational number, anything it is. Okay. Therefore, the same formula of integration applies in the form of ax plus b, but in the a, 1 minus x is nothing but x minus x plus 1. Therefore, ax plus b in the form of ax plus b. A is what? Coefficient of x minus 1. We can write 1 minus x as minus x plus 1, 1 and the same, 1 is plus, x is minus x. Therefore, ax plus b form, a is minus 1. Try to listen all those things, even minute things are explained in each and every videos. Videos and clean alwa observe ಮಾಡಿ ಕಿವಿ ಹಾಕೊಂಡು ಕೇಳಿ ರಿವೈಸ್ ಮಾಡಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಪಾಠ ಕಲಿತ್ಕೊಳ್ಳಿ ಎಲ್ಲರೂ ಅಲ್ವಾ? ಬರೀ ಎಕ್ಸಾಮಿಗೆ ಬೇಕಾಗಿರುವಂಥ ಥಿಯರಿ ಕೂಡಿ ನಾವು ಬರಿತೇವೆ ಅಂತಂದರೆ ಅಲ್ಲ, ಆಗೋದಿಲ್ಲ ಸೈನ್ಸ್ಗೆ. ಸೊ ದಟ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು it is n is half, therefore a is 1, n is half. Then therefore the answer is ax plus b. There is nothing wrong, no need to write. It is minus x plus 1. 1 minus x, understood. X coefficient is minus 1, therefore a is minus 1, understood. Therefore you can take it as it is only. No need to write minus x plus 1. Okay. 1 minus x raised to half plus 1 upon a. A is minus 1 into half plus 1. Is it not? Ax plus b. Ax plus b is 1 minus x here. B is 1, a is minus 1. Raised to n plus 1 upon a. A is minus 1. High a is minus 1, it is given in the problem. That's equals to 1 minus x raised to half plus 1 is 3 by 2 upon half plus 1 is 3 by 2. LCM 1 plus, for this 1 2 multiplies, 1 plus 2 is 3, 3 whole divided by 2, minus 3 by 2. Now it is multiplication is taken, minus 3 by 2 is multiplied, denominator is multiplied, a upon b divided by c by d equals to a by b into c by d multiplies by taking reciprocal d by c. Therefore it is minus 2 by 3 into 1 minus x raised to 3 by 2 plus c. 3 by 2 is upon 2 is square root. Whole raised to upon 2 is square root. Therefore it is minus 2 by 3 into square root of 1 minus x whole cube. 1 minus x whole cube raised to 1 by 2. It is 1 by 2, no? Upon 2 is 1 by 2. Whole raised to 1 by 2 means it is square root. Yesterday only it is mentioned, it is x raised to p by 2 is nothing but cube root of x raised to p. If it is 2, then it is 2, no need to write 2 because so this means square root. ಇಲ್ಲಿ 2 ಇದೆ ಅಂತ 2 ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. If it is 2, then there is no need to write 2 here. Understood? 2 is there. Nothing is written here. The radical index is 2 here. Cube root of, it is cube root of, it is x raised to p. Q is 2 here, but no need to write 2. 3 ಇದ್ರೆ ಬರೀಬೇಕಾಗುತ್ತೆ. Suppose 3 cube root ಇದ್ರೆ 3 ಬರೀಬೇಕು. Upon 4 ಇದ್ರೆ 4 ಬರೀಬೇಕು. Upon 5 ಇದ್ರೆ 5 ಬರೀಬೇಕು. But 2 ಇದ್ರೆ ಬರೀ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. Next one, third one. It is integration of 1 upon, it is cube root of 3x minus 1 whole raised to 5. Third example. Okay, cube root of 3x minus 1 whole raised to 5. That's equals to, it is 1 upon whole raised to 5 means it is 3x minus 1 whole raised to 5 by 3 dx. Because it is cube root of x raised to p equals to x raised to p by 2. Not only x, any function of x, f of x raised to p. Cube root of f of x raised to p is f of x raised to p by 2. Therefore f of x is, no, cube root is there. So it is cube root. This 3 is inside the radical side. This is the radical side 3. Therefore, it is 5 by 2. Therefore, the integration of 3x minus 1 raised to minus 5 by 3 dx. Because there is no formula for 1 upon ax plus b. Only ax plus b raised to n, whole raised to n. Therefore, this is taken as 1 upon a raised to m is a raised to minus n. Now integration formula. Now exactly in the form of ax plus b whole raised to n. N is minus 5 by 3. N is any positive real number or negative real number except minus 1. Therefore, it is a is 3. N is minus 5 by 3. Apply the formula of integration. Now, this particular form is exactly the integrable form. Integration ಮಾಡುವ ಸ್ಟೇಜಿಗೆ ಬಂದಿದೆ. Integration ಮಾಡುವ ಸ್ಟೇಜ್ ಅಂದ್ರೆ integration formula ಹಚ್ಚೋ ಸ್ಟೇಜಿಗೆ ಬಂದಿದೆ. Integration formula ಹಚ್ಚಿಬಿಟ್ರೆ ಆಯ್ತು ಅಷ್ಟೇ. So that is equals to ax plus b whole raised to n plus 1 minus 5 by 3 plus 1 upon a, what is a? 3. So when the integration formula is taken, no more write, don't write the integration sign again. Okay? Integration of ax plus b whole raised to n is equals to what integration sign won't comes. Ax plus b whole raised to n plus 1 upon n plus 1. It is a is 3 into n plus 1. Now take the LCM. Minus 5 plus 3, LCM. Minus 5 plus 3 is minus 2. That's equal to 3x plus 1 raised to minus 2 by 3 upon 3 into minus 2 by 3. It cancels. Then minus 2 as it is, minus is taken to the numerator. It is minus 1 by 2. This minus goes to the numerator. Simply it comes in between actually. Minus 1 by 2 upon 3x raised to minus whole raised to minus 2 by 3 means it is 3x minus 1 whole raised to 2 by 3. Because again same technique is taken. This minus 2 as it is, minus is here. So a raised to minus m is 1 upon a raised to m. So that's equals to minus 1 upon 2 into it is cube root of, it is 2 by 3 is cube root of 3x minus 1 whole raised to 2 plus c. No, 2 by 3 is cube. Now you have to write inside the radical side this 3 is to be written whole raised to 2. Okay. These are all the examples of how to integrate ax plus b raised to n. Second one, integration of 1 upon ax plus b dx. Same substitution. Let us take t is equals to ax plus b. Ax plus b, just refer the previous what? Differentiating with respect to x. I got in short, I will write because in the previous example only that is taken, dt is equals to dt by n is equals to dx. Okay. dt by dx is equals to, in short, differentiating with respect to x, dt, t differentiation is dt by dx, ax differentiation is a. Therefore, dt upon a is equals to dx. Across multiplication, dx goes dA is cross multiplied. Therefore, integration of 1 upon t is dt by dx is dt by. Because whenever we see it in terms of t, here dx will not do, that dt is necessary. That's equals to 1 by a into integration of 1 by t dt. That's equals to 1 by a, integration of 1 by t is log t. 1 by t is log t plus c. Okay, that's equals to 1 by a. Finally, we should get back to the original variable ax plus b. Plus, therefore, just remember it as, that's all. 1 by x integration is 1 by t integration formula. 1 by x log x, 1 by t integration log t. There is a substitution there. By substitution, as it is, there is no integration formula. So, I have to reduce it to a form by taking proper substitution where integration formula is applicable. Okay, 1 by t integration is log t, 1 by x integration is log x, 1 by t is log t. That's equals to 1 by log of ax plus b. So therefore, integration of formula, just to remember the formula, 1 upon ax plus b. You can't take it as raised to 1. Ax plus b, previous example technique is not applicable for here. Ax plus b means ax plus b raised to n taken to the numerator, ax plus b raised to minus 1. Then minus 1 ax plus b whole raised to n integration. Minus 1 plus 1 upon minus 1 plus 1. Minus 1 plus 1 is 0, upon 0 comes. Therefore, n should not be equals to minus 1. In that formula, ax plus b whole raised to n formula, n should not be equals to minus 1. Then upon n plus 1 will become minus 1 plus 1. 0 upon 0 is not defined. Therefore, ax plus b whole raised to n, ax plus b integration is dx. Even you can take dx in the numerator like this. Immediately, you can write like this, dx upon ax plus b, that's equals to ax plus, the log of, I told the final answer, modulus should be taken for the function in front of log. Question is the modulus to be, because log is not defined for negative numbers. Mod is taken. Okay. For example, oh my god, time is up. For example, in the last video, last problem is incomplete. Now I will complete it in the next class. For example, integration of 1 upon 3x plus 5 dx is equals to a is 3, 1 by 3 log of 3x plus 5 plus put mod 1 upon ax plus b is 3x plus 5, 1 by a log of ax plus b plus c. Okay.